In this video, we're going to look at a subtle difference on how you can send information to a function and different ways you can send those variables. One is called call by value, which is the usual way of doing things, and then another slightly different one called call by reference. And just to sort of motivate the need to understand the difference between these two, imagine you have a program where you've got a couple of variables, x and y, and their values are 7 and 12. And your desire is to have a subprogram, maybe we'll call it swap, a function, go in, grab those variables, and do nothing but switch them. Just switch them around so that when you're done, x takes on the value of y, and y takes on the value of x. It seems sort of simple enough, but we can actually run into some little challenges here. So the desired output would look something like this. If you were to print off the values of the variables before the swap, they're 7 and 12, but then if you were to print them off after you've done that function, that subprogram, you're going to get 12 and 7. So you might have a main program that looks something like this, and we'll step through it here in a minute, but in the middle of it, we're going to have this little instruction that says, all right, go and swap x and y. We're going to get that little function to go and do its business, and then we'll come back to the main program and then print out what it looks like after the swap. So we'll have to go and declare and define what swap looks like up above the main program, as always, and it might look something like this. Maybe you say, okay, this subprogram, this function swap, doesn't really need to return anything special back. It just needs to switch the variables around. And you might think that this code would actually work. We'll have a little temporary variable, as always, when we're switching things around, and we'll just go through the little dance of switching the values of A and B, and then return back to the main program. But it doesn't actually work. Here's what happens. We step through the main program. The first thing that happens is we actually declare that we need to have some integers, x and y. And so your computer goes and reserves some spots on the memory, saying, yep, I need to be able to save x and y, but there's nothing in them yet. Then we get to this section of the code where we're going to store 7 and 12, and then we're going to print off the values. Okay, so 7 and 12, as you can see on the left, get stored into those locations in memory. Yep, and on the screen, everything gets printed off. Things are fine. Then we go to try to execute the swap, and we're going to send those values of 7 and 12. But here's the problem. We don't really send the variables. We only send their values, 7 and 12, to that little subprogram called swap. So here's the actual declaration or definition as well of swap. It says, yep, we got some integers coming at us, and I've very deliberately not used x and y just to sort of show what's going on here. I've called them A and B. And then we'll make another variable in there called temp along the way. So at this point, we're going to do what's called call by value. This is the normal way of doing things. We're going to create some extra spaces in memory called A and B, and we're going to make copies of those values, 7 and 12. And now that subprogram is working with the variables A and B. Okay, we're going to need another variable called temporary to do our little dance of switching the variable values around. So okay, great. Inside the scope of that subprogram, that function, we now have another variable called temp that we can access during this function. And here comes the little dance where we first save the value of A, and then we switch the value of A, and then finally go and switch the value of B. And so that little crazy dance looks something like this. First we save the value of A so we don't lose that 7. Then we're going to say, all right, go and copy B into A, and no problem, we haven't lost the information about the 7. We can then finally go and copy the 7 back from temporary into B. Things look good, at least as far as A and B go. Then we're going to return back to the main program, and here's where things get kind of interesting. When we return back to the main program, yeah, we're going to come back right here, right after that function called swap. But when we do, we lose access to those 3 memory locations, A, B, and temp, the ones that we've created in that subprogram. They're now gone. They're now out of scope. You can't see them anymore. All you see are the original x and y's, which are still 7 and 12. So when you get to this section of the program, even though you successfully changed A and B, those are gone. You don't have access to them anymore. When you do your printout on the screen, it just still disappointingly says, oh yeah, we've got 7 and 12. So we've got to do something different. And you might be thinking, well, the trouble is you use the letters A and B. You can see them up there in the declaration of void swap. What you really should do is change that to X and Y. Well, that's a nice idea, but it doesn't help at all. What happens is you end up generating inside the scope of the function another set of variables that are also called X and Y, but inside that subprogram you'll be accessing that second set of X and Y. And then they'll be gone, they'll be out of scope, and the original X and Y then are back in play. So you'll actually at times have multiple versions of a variable in play. And during the scope of that subprogram, you'll have those green ones, so to speak. But then when the subprogram is done, you're back to the blue. So just changing the names doesn't actually help. We have to do something very, very different. And that's actually what we call by reference. We're basically going to be using pointers, memory addresses. During this spot, when we say swap x and y, we don't want to send in the values 7 and 12. We want to find a sneaky way of letting the function, the subprogram, know about where x and y physically are on your computer. And we're going to make a little change. It's minor. Up at the top, you can see we've used that ampersand. So we're basically now saying, hey, don't tell me about the 7 and the 12. Tell me about the addresses of the memory location where 7 and 12 are currently stored. Beyond that, you don't need to change much of anything else. Now when we go through this spot in the program called swap, the main program looks identical. Now these things that are generated, these A's and B's and temps, they're not really the values 7 and 12. They're just addresses. They're like pointers that are pointing at those memory locations. And we can go through our crazy little dance where we create the temporary one that's equal to where A is pointing, and then switch A and then switch B. It looks kind of messy, but basically we're just switching the addresses around. And that way, when we're done, we're actually going to have switched 12 and 7. We've in a sneaky way passed information to that function, that subprogram, that lets it know where it can access the x and the y. It's now directly accessing those memory locations and switching them around. And then it actually works. When you come back to the main program and you print your after the swap, it does successfully show that we've switched those two values. So instead of sending the values 7 and 12, we've sent in a way of addressing where they're actually located. That way that function can use those addresses, even though they're just actual values of addresses. It can take those values for the addresses and then successfully find them on the memory and make the switch. There's one last little thing. When you're playing this game with arrays, just like you might be doing on the final assignment for the tic-tac-toe game. When you pass an array, arrays are kind of pointers by nature, and you have to actually do it in a slightly different way. So what you see at the bottom of the screen here is a way that you might come up with a plan to just initialize your game board with your 9 spaces. If you want to number them 1 through 9, of course you might have declared 10 of them in the main program, as you can see down below. And I want to send the game board array to this function, this subprogram called initialize the board, just to get everything set up. I don't want to see that in my main program. Instead, I'd rather see that phrase, initialize board. So up in my declaration of this initialize board function, I need to put the little dereferencing star on there so that it can actually do this correctly. Now it will be able to directly access that particular array and then make changes to it and set up all the original spaces on the tic-tac-toe grid to be empty or 0 or whatever you prefer. So that's the plan. Normally we do call by value, but there are sneaky ways of doing call by reference if you find you have to actually be making changes to the original variable. There's another way to do this with some things called global variables, but we're going to stay away from that for now. Many people will tell you you should be staying away from global variables as much as you can anyways. So that's the end of the video for call by value and call by reference.